Alright, my name is Stevie Adam Kwasamuel. You are once again welcome to my channel. If this is the first time you're watching my video, don't forget to subscribe. And also, don't forget to hit on the notification bell for updates. Alright, so consider this example in case you're given this one, A times A times A times A. So we have 1, 2, 3, 4. So this one, it means A to the power 4. Now what this one means is that the number of times this number or this variable is multiplying itself. So it means the number of times A is multiplying itself. So the 4 here means that A is multiplying itself 4 times. Alright, so in case we're given, let's say, t to the power 5. Now this one is telling us that this t is multiplying itself the number of times, that is 5. Alright, so this one is the same as t times t times t times t. Alright, so 1, 2, 3, 4, 5, so 5. Alright. So we call the down one base and this one index. Alright, or power. Alright. So this one means that A is multiplying itself 4 times. Alright, so this one is power or index and this one is base. So this one will send us a topic called indices. So today we are going to look at a topic called indices. So this one is the base and this one is the power. Alright. So let's quickly look at the laws of indices. Now the first law I will talk about is A to the power C times A to the power N. Now let's work something here. Now this one is base, this one is base. So what can you say about the base? The bases are the same. And the law says that if the bases are the same and they are multiplying, you only pick one of the bases. So I'll pick one. Then I'll add the exponents. So C plus N. Alright, so in case we're given, let's see, 5 to the power 7 times 5 to the power 2. This one, since I have 5 here, 5 there, I'll just pick one, then add the base, which is 7 plus 2, which is 9. Alright, so this one means that 5 will multiply itself 9 times. Alright, so this one is also the same as 5 multiplying itself 7 times. Then this one, 5 multiplying itself 2 times. If you combine, you get this one. Alright, so that's the first law. Now the second law is division. In case we are given A to the power C divided by A to the power N. Alright. So this one, we have the same basis, so I'll pick one. Now let's check something here. This one is multiplication and this one is division. And the law says that if it is division, you just subtract the exponent. So C minus N. Alright. So let me summarize this one. In case we are given division, will tend to subtraction, and multiplication also tend to addition. Alright. That is the summary of this one. So this one, in case we are given, let's say 2 to the power 2 divided by 2 to the power 5. So this one is straight away 2 to the power 2 minus 5 because I have equal bases, so I'll pick only one. So I will subtract the exponent. So 2 minus 5 is minus 3. So 2 to the power minus 3. Alright. Now let's move on. Now before we move on, this one is division. This one is the same as or A to the power C over A to the power N. And the same as this one is division and division, they are the same. I'll just pick one and subtract the exponents. So this one is the same as this one. Alright. So the third law. So in case we are given, let's say, a to the power x times t. Alright. Now, this one is a power, this one is a power. So the law says that this one can multiply this. So this one is s times t. So this one is same as a s. Alright. A s. So in case of using 6 to the power 4, then I have the all to the power 2. This one is the same as 6. Then multiply 4 times 2. This is 8. Alright, so that is that. Now let's consider this example. Now we have this one. So this one is the third law. So this one is to the power 2 all times to the power 4 divided by this one. So this one is the same as 2 to the power. So 3 times 4 is 8. So this one we multiply this that. So division sign will come. And this one we have this 2 to the power 5. So this one is division, and we know division is subtraction. We are going to subtract the exponents. So this one is straight away 2 to the power 8 minus 5. So 8 minus 5 is 3. Alright. So this one. Alright. So we have 5 to the power 4 divided by 5 to the power 3. Alright. So this one will cancel this. So we are left with to the power 4 divided by to the power 3. So this one I have 4 here, I have 3 here. So I have to the power 4 minus 3. So which is to the power 1. Alright. So to the power 1. Yes. Alright. Now let's move on. So I have 6 to the power 4 times this one. So this one, so 6 to the power 4 times. So this one is the third law, 3 to 6. So 6 to the power 6. So this one is multiplication. And the law says who is multiplication, we add the exponent. So I have this one. Alright. Now the law only holds if the weights are the same. Don't forget that one. Alright. So I have 6 to the power 10. Alright. So the last example. So can you try this one? So just pause the video and try this one. Alright, so this one 2, 3, 6. You have b to the power 6 divided by, so this one is 5 times 2 is 10. 10. Alright. So this one is division. Then division we subtract. So I'll pick one of the bases. Then I'll subtract the exponent. 6 minus 10 is minus 4. So b to the power minus 4. So it's not 4 but minus 4. Alright. Alright, let's talk about properties of indices. Alright. So properties. Alright, now the first one, any non-zero number to the power 0 is 1. So in case you are using this, a to the power 0 is 1. Alright, so any non-zero number to the power 0 is 1. So 5 to the power 0 is also 1. So 0.045 to the power 0 is 1. Don't forget this one. So that's the first property. Alright. So now the proof is coming from here. So let me prove the reason why this one is got this. Alright. So in case now this one, let's say a to the power 4 divided by a to the power 4. Alright. Now you know that this one is the same as e to the power 4 over e to the power 4. Alright. So let's solve the left and then the right and see. Now, this one, let's apply the law here. The law is using division, we subtract. So e to the power 4 minus 4, which is e to the power 0. So for this side. Now this one is also the same as the number of times a multiplied itself is 4. So a times a times a times a over. So this one is a times a times a times a. So this one will cancel this 1 1. This one will cancel this 1 1. This one will cancel 1 1. So this one will cancel this. So 1 times 1 times 1 times 1 is 1. 1 times 1 times 1 is 1. So 1 over 1 is 1. Alright. So we have this 1 e to the power 0 and we have 1. And since this 1 is equal to this, now we can say that e to the power 0 is equal to 1. So any non-zero number to the power 0 is equal to 1. Alright. So any number to the power 1 is that number. So any non-zero number to the power 1 is that. So this one is equal to a. Alright. So the first one, e to the power 0 is 1. And the second one, e to the power 1 is a. So don't forget this one. Alright, so we have this one. Alright. So e to the power 1 is 8. So 5 to the power 1 is 5. Alright, so 6 to the power 1 is also 6. So 17 to the power 1 is 17. Alright, so that's that. Right, let's move on to the next one. Alright, so this one is negative index. So in case we're given a to the power minus 1, now this one is the same as 1 over a. So c to the power minus 1 is the same as 1 over c. So y to the power minus 1 is the same as 1 over y. Alright, so what if here is 2? That is minus 2. So if here is minus 2, so in case we are giving a to the power minus 2, so this one is the same as 1 over a to the power 2. Now the trick here is that the moment you write this 1 over, then the minus will vanish. Alright, so we assume that the 1 is still there. And we know from our second problem that any non-zero number to the power 1 is that number. So we assume that here is 1. Okay, so a to the power minus 1 is the same as 1 over a. Alright, so if here is 2, the 2 will come. So c to the power minus 3 is the same as 1 over c to the power 3. So the moment you write this 1 over, then the minus will go. Alright, so that's that. Now let's move on. Now the fourth one. Alright. So in case you are using this one, a over b to the power or to the power n. So this one is the same as, now the power will affect everything in the bracket. So this one is the same as e to the power n over b to the power n. Alright. So in case we're given, let's see, x over y all to the power 2, this one is the same as x to the power 2 over y to the power 2. Alright, so don't forget this one. So in case we're given this 3 over 2 all to the power 2. So this one is the same as 3 to the power 2 over 2 to the power 2. and 2 to the power 2 is 9, then 2 to the power 2 is 4. Alright, so that's that. So don't forget this one. Alright. Now, the fifth one, AB all to the power T. Now, what this one means that the T will affect everything. So this one is the same as e to the power T, then b to the power T. So this one is that. So this one will affect this at the same time this. So example, give you're giving, let's say 2x to the power 5. This one is the same as 2 to the power 5. So this one is multiplication, so times x to the power 5. Or you can also say 2 to the power 5, x to the power 5. They are the same. Alright, so this one is multiplication. Alright, so that is that. Alright. Now, what if here is minus? So let's deal with that one. So in case that is minus. So in case of this one, it will be minus n. Alright. Now, so the moment you see this one minus, this one is the same as, so just interchange this one to b over a. The moment you do that, this one also change to positive. Alright, so in case you have c over n all to the power minus t. So this one is the same as n over c. Then this one also change to positive. The moment you interchange this one, it also change. Alright, so don't forget this one. So in case we're given this one, 6 over 5 all to the power minus 1. This one is the same as 5 over 6 all to the power 1. And in the number to the power 1 is that one. It is the same as straight away 5 over 6. Alright, so it's not very simple. Alright. Now let's quickly move to fractional index. So in here we have a to the power half. So a to the power half is the same as square root of a. Don't forget this one. So every time you see a to the power half, the same as square root of a. Now a to the power 1 over 3. Okay, this one is the same as cube root of a. So this one is this. Now somebody will ask, why is that here is not 2, here is 3? Now this one is the same as this. So if you put 2 here, it becomes tautology. Okay, alright. So you can't put 2 here. Okay, it's like saying return back. Okay, doesn't sound well. Alright, so this one is the same as this. So from 3 going, we put it here. So in case you have a to the power 1 over 4, the same as fourth root of a. Alright, then if you are given, let's say, a to the power 1 over n. So let's say something. So this is 2, this one is the same as this. 3, you see it, 4, you see it, but 1 over n. So let's get this one. So this one is same as n root of a. Alright. Now, what's something here? You can see 1, 1, 1, 1. So what if here is 3, here is 2, here is 2, here is, let's say 5, here is 6. You see 1, 1, 1. What if you don't see 1, but you see different number? Now let's work something here. Now, this one, we assume that is all to the power, what is here, 1. So this one, we have 1, we assume that is all to the power 1. So this one is the same one, we assume that is all to the power 1. Because of the 1, 1, 1, 1. So to the power 1, 1, 1, 1, Alright. Now this one, any non-zero number to the power 1 is that number. That's why you don't see the 1 there. But ideally, this one is supposed to be to the power 1, to the power 1, to the power 1, to the power 1. Okay? So in case you're giving, let's say, a to the power 5 over 2. Alright. So here is 5. Now this one is the same as, so I can rewrite this one as a to the power half or to the power 5, because half times 5 is the same as 5 over 2. Alright, and this one, you know this one is this. Okay, a to the power half is here, a to the power half is there, which is this one. So this one is the same as a or to the power with a 5 in there, 5. Alright, so in case you're using this one, a to the power 7 over 2. Now this one is the same as a to the power half or times 7, because half times 7 is 7 over 2. Half times 7 is the same as 7 over 2. So this one can be written like this. So this one is the same as square root of a all to the power 7. So that is foundation. Alright. So this one, let me take my time here. So this one, the power is 5 over 3. So this one is the same as t, okay, to the power 1 over 3 or times 5. Now, in going back, 1 over 3 times 5, so 1 over 3 times 5. So let's make this 1 over 1. So 1 times 5 is 5. 3 times 1 is 3. So 3 over 5. Okay. So 5 over 3 is here. Okay. So this one is the same as this. And we know 1 over 3, t to the power 1 over 3 is the same as cube root of that. So cube root of t. So over 5 will also come. Then you do it. That is. Okay. So you want not to confuse yourself. That is how you go about. You don't confuse yourself. Always the top one, bring the top one out. Okay. So we are left with 1. 1 times 5 is 5. And we know how to write this 1 over 3 is same as cube root of that. Now m over c. So m over c is the same as a to the power 1 over c or to the power m. You see the top one always cancels out. Okay, this one 5, see the 5. So 1 over c is the same as the c root of a or to the power m. I hope we are getting it. So this one is 5 8 over 3. So how do you buy this one? So this one is the same as 5 1 over 3 all to the power 8. And this one will give us cube root of 5 all to the power 8. Alright. So let's try this one by example. T over c. T to the power p over c. So this one is same as t 1 over c all times p equals, so this one is t 1 over c is same as the c of t all to the power p. Alright. So let me give you some to try. So this one is the same as 5 to the power 1 over 7 all to the power 9, which is the same as the 7 root of 5 all to the power 9. And this one 3 over 2 is the same as 6 1 to the power 1 over 3 all to the power 3, which is the same as the c root of 6 c root of 6 all to the power 3. Alright, so that's that. So these are the examples. Alright. Let's consider the following examples. Now I have 2 to the power 1 over 2 times e to the power 1 over 2 all over 4. Alright. So let's use the law, and remind you, before you can use the law, you have to make sure we have equal bases. We have 2 here, we have 4 here. Unless you change something. Unless you change this one. So this one is the same as 2 to the power half times. So let's change this one. We know 8 is the same as 2 times 2 times 2. 2, 2, 4, 4 to 8. So 8 is the same as 2 to the power 3. Now, this number alone is given as 2 to the power 3. But we still have exponent that is 1 over 2 there. So this one is the same as 2 to the power 3 times, so the half will come. So this one is the third law. So in case you are given this one, a to the power n, or to the power x, so you just multiply nx. Alright. So I have that. So over. So let me also change this one to 2 to the power 2. Alright, so that you get equal base. That is, you get the base to be the same. 1, 2, 3. The bases are all the same. Alright. So let's move on. So let me multiply this one. 3 times half. Is take away 2 half times. So 3 and half, 3 times 1 is 3. So 2, 3 over 2 over 2 to the power 2. Alright. So I'll deal with the numerator. So this one is multiplication. That's the first law. We said multiplication, if the bases are the same, you can add the exponents. So this one, you can add the exponents. 1 over 2 plus 3 over 2. That is 4 over 2. So that is 1 over 2 plus 3 over 2. Today, LCM is 2, so I have 2 there. So 2 into 2 is 1. 1 times 1 plus 3, which is 4 over 2, which is 2. So this one I will get 2 to the power 2. Alright. Over 2 to the power 2. Alright. So this one over this, they are the same. So straight away, the answer is 1. Or you can say this one is division. So you can perform the law, which is, so this one is division, so I'll subtract. So 2 to the power 2 minus 2, which is what? 0. And any non-zero number to the power 0 is 1. So since this one is 2 to the power 0, which is 1. So this one, the answer is 1. Alright. Alright, let's look at the second example. Now this one, we can use 2 ways to solve this. Now the first method, before we move on to the methods, now I have minus here, minus there. So let's, don't forget this. So in case you are given this one, a to the power minus n is the same as 1 over a. So we are going to rewrite this one such that we get positive exponent. Exponent should go positive. So let's make this one positive by saying 1 over 125 to the power 1 over 3 times 1 over 49 to the power 1 over 2. Alright. So with this, you can use 2 methods. Now the first method I'll talk about. Now I have the power to be 1 over 3. So let's change this number. Okay. to a number to the power 3, which will give us 125. So 125, we know 5 times 5 times 5 is 125. So we are going to change this one to 5 to the power 3. So this one is same as 1 over 5 to the power 3. Don't forget we have 1 over 3 here, so that one also multiply 1 over 3 times 1 over. Now this one here is 2. So find a number, make multiply yourself twice, that will give you 49. So we know 7 times 7 is 49. So 7 multiply 7. So 7 to the power 2 times 1 over 2. Alright. Now we are doing this because we want to do cancellation, that's why. So this one will straight away cancel this. 2 will also cancel it. Right. So this one, I have 1 over 5 to the power 1, which is 5. So I have 1 over 5 times 1 over 7. So 1 times 1 is 1. 5, 7, 35. Alright. So that's the first method. So let me use the second method. So I have this one, second method. So this one is the same as 1 over 125 the power 1 over 3 times 49. Sorry, 1 over 49 to the power half. Alright, now we said if this one is 1 over 3, the same as cube root of this, and this one is square root of this. So this one straight away you can say 1 over cube root of 125 times 1 over square root of 49. Alright. So don't forget that we said in case you are giving e to the power 1 over 3, the same as cube root of a, and 8 to the power 1 over 2, the same as square root of a. We said this one in our properties, so don't forget this. So this one will give you, so use your calculator. So press shift, then press the root sign, give you this one. So make this one 3, or even the 3 is there. If you want to move forward, you have to bring the color here and then change this one. Alright. So press this one, let's see. So you get 5 for this one. I have 1 over 5 times, so square root of 49 gives you 7. 1 over 7, that is positive square root of 49. So this one is straight away 1 times 1, 1. 5 times 7 is 35. So this one is the same as this. So whichever way you go, get the same answer. Alright.